So my name is Kazi Anikamed. My ID is N154605997, and today I'll be doing homework problem 3.8 for homework 2. So we're given a system of h of z, which is 1 minus z negative 1, z inverse 1, divided by 1 plus 3/4 of z inverse 1. Now, we are also given the input to the system, which is x of n equals 1/3 to the power of n times u of n plus u of negative n minus n. So for A, we are asked to find the impulse response of the system h of n. So we can take h of z, that's given, which is 1 minus z inverse, divided by 1 plus 3/4 z inverse. Now we can easily, using the z transform, we can equal that to just simply writing it z minus 1 divided by z plus 3/4 using z transform. Now if we set the z plus 3/4 equal to 0 to solve for ROC, we can see that the ROC of z will be greater than 3/4. So we have the ROC for h of z. Now, and we can say that because the system is causal. Since we're told that the entire system, it's a causal LTI system, so we are assuming that. And then from h of z, we have z divided by z plus 3/4 minus z inverse multiplied by z divided by z plus 3/4. From that, we can set that equal to, from h of z to h of n equals, using z transform to get it in h of n formula, we can write that simply by negative 3/4, since that's z divided by z plus 3/4, negative 3/4 to the power of n, still z transform, times u of n, minus, because that sign is also minus, negative 3/4, because if that's minus and this is plus, this inside must be minus to make it positive. Negative 3/4 n minus 1. Why n being shifted? Because we have a z inverse 1. Z inverse, and that multiplied by the shifted u of n, which is u of n minus 1. So we have A, and we found the impulse response of h of n. Now for B, we're asked to find the output y of n. So we can write x of z equals z divided by z minus 1/3 subtracted by z divided by z minus 1. Now we can simply do some algebra and have common denominator, and we can write that z minus 1/3 times z minus 1/3 times z minus 1. On the top we'll have negative 2 divided by 3 of z. And if we solve for the ROC, we'll see that the z will be in between, not touching it, but in between 1/3 to 1. And we get these numbers from right there. And now y of z, we know that it's h of z times x of z. X of z we just found, so we can write that as negative, this is just across, negative 2/3 z divided by z minus 1 times z plus 3/4. And once we multiply h of z and x of z, we get this. From there on, from these two denominators, we can see that the ROC z is greater than 3/4. So just a theorem. So where the ROC of the y of z is obtained, so the ROC of this y of z is obtained by using the fact that the ROC y of z, which is this right here, must contain the intersection of the commonalities of the ROCs of x of z and h of z. H of z is right there, h of z is right there. Now, inverting the y of z that we just found, if we just invert it, we can find that it's negative 2/3 z, which I already just wrote right there, so I'm just rewriting it. We can simply equal to, and if we do partial fraction, we can do that negative 8/13z equals the first denominator plus 8/13z divided by the second denominator. And from here on, we can do the z transform to get it in this function. We can write that negative 8/3 will come out, and it will be 1 over 1/3, since that's already negative, and we have written negative right here. This is just going to stay positive, 1 over 1/3 n u of n plus 8/3 will come out, and we'll have a negative 3/4, because this is positive. This is if this is positive, should this be positive? Yes. So this is 8/3 minus 3/4, since that's positive. So we write that as negative 3/4 n times u of n. So we have the y of c, the output. Now for c, we're asked, is the system stable or not? The system is stable. We can assume, not assume, we can confidently say that, because the ROC contains the unit circle. It's within that unit circle, so we checks off all the boxes. So the system is stable. Thank you.